In this example, we have 2y double prime plus y prime minus y equals x plus 1. We have gx as x plus 1. This equation can be solved using the undetermined coefficient as well, but this time we're going to use the variation of parameters. Step 1. Find yc from the associated homogeneous equation, or from the equation 2y double prime plus y prime minus y equals 0. And using the auxiliary equation as 2m squared plus m minus 1 equals 0, factor completely to get 2m, m here 1 and 1. This is plus sign, this is minus sign equals 0, or we get m equals 1 over 2, or m equals negative 1. So the solution y1 is e to the 1 half times x. The solution y2 is e to the negative x. As a complementary solution, we have yc equals c1 e to the 1 half x plus c2 e to the negative x. Step number 2, we're going to find the Wronskian of y1 and y2, which is the Wronskian of e to the 1 half x and e to the negative x. Form the determinant of the 2 by 2 matrix. The first row are contains two functions, which is e to the 1 half x and e to the negative x. Second row is its derivative, which is 1 over 2 e to the 1 half x and negative e to the negative x. And then use the Cramer rule. Multiply crossway down. That would give us negative e to the 1 half x times e to the negative x. And crossway up, we would get 1 half, negative sign, 1 half e to the 1 half x times e to the negative x. Simplify the power of the exponential term. We get negative e to the negative 1 half x. And the second term is negative 1 half e to the negative 1 half x as well. Combine these two to becomes negative 3 over 2 e to the negative 1 half times x. Step number 3. We're going to write equation in the standard form with the leading coefficient is 1. So divide all by 2 to get y double prime plus 1 half times y prime minus 1 over 2 times y equals x plus 1 divided by 2. With this form, we have the f of x equals x plus 1 divided by 2. Next step, we're going to use this to find the W1 and W2. W1 is the determinant of the 2 by 2 matrix, which the first column is 0 and the f of x. And the second column is the y2 and y2 prime, where W2 is the Wronskian as well, but the first column is y1, y1 prime. And for the second column, it's 0 and the function f of x. For Wronskian 1 or the W1, the 0 and the f of x is x plus 1 divided by 2, and the y2 is e to the negative x, and y2 prime is negative e to the negative x. Find the Wronskian. Cross way down, we get 0. Cross way up, we get negative of the x plus 1 divided by 2 multiplied by e to the negative x. And for W2, which is the determinant of the 2 by 2 matrix, which the first column would be y1 and y1 prime. Y1 is e to the 1 half x, and its derivative is 1 half e to the 1 half x. Second column would be 0 and the f of x, which is x plus 1 divided by 2. Use the Cramer rule. Multiply cross way down. We have e to the 1 half x multiplied by x plus 1 divided by 2, subtracted by 0 this time. So then we get W2 as e to the 1 half x multiplied by x plus 1 divided by 2. Step 4. We're gonna find U1 prime and what we're gonna find U1 and U2 from U1 prime and U2 prime. So from U1 prime, which is the W1 divided by W. W1 is negative x plus 1 divided by 2 e to the x divided by W means multiplied by the reciprocal. The reciprocal of W is the reciprocal of negative 3 over 2 e to the negative 1 half x. So we have to be careful with algebra at this step. So the W, which is negative 3 over 2 times e to the negative power, you can write as a positive power as 1 over e to the 1 half x, and write it as 3 divided by 2 e to the 1 half x. So W1, which is negative x plus 1 divided by 2 times e to the x multiplied by the reciprocal of the W, which is multiplied by 2 times e to the 1 half x divided by 3. 2 and 2 reduce, simplify the term. Now we have negative x plus 1 divided by 3 e to the 3 over 2x. From U1 prime equals negative quantity x plus 1 divided by 3 times e to the 1 half x. We can find U1 by finding the antiderivative of negative x plus 1 times e to the 1 half x divided by 3 with respect to x. Using bypass technique, we will get U1 as negative 2 over 3 times x plus 3 multiplied by e to the negative x over 2. Similarly, U2 prime, which is W prime, W2 divided by W, and W2 is e to the 1/2 times x multiplied by x plus 1 divided by 2 and multiplied by the W2, multiplied by the reciprocal of the W, which is 2 e to the 1/2 x divided by 3. 3 and 2 cancel to get e to the 1/2 x times e to the 1/2 x is going to be e to the x or x plus 1 to the power rest multiplied by e to the power 1x. And similarly, we use the bypass technique to find the solution u2. And then we get u2, which is the integral of x plus 1 times e to the power x divided by 3 with respect to x equals negative 1 over 3 times x e to the x as y is u2 solution. And then step number 5, your yp, which is u1 times y1 plus u2 times y2, and u1 we just obtained, which is negative 2 over 3 times x plus 3 times e to the negative x over 2. That's u1 multiplied by y1. y1 is e to the negative x over 2, and the u2, which is negative 1 over 3 x e to the x times the y2 solution, which is e to the negative x with this we get yp equals negative x minus 2.